Hi friends, welcome back to Hobby Plus. Today we will learn how to make a DC power supply for our testing lab. That is very easy and simple. I also discuss everything one by one. First of all, you need a transformer. We cannot use here a SMPS. That is more difficult. So we are going to transformer circuit. You must have a 2 ampere or 3 ampere SMPS. 2 ampere or 3 ampere transformer. Now I will discuss how we decide what is the output ampere of this transformer. First of all, you can get it from a market or a defective UPS. Open it and arrange this transformer. After that, you put here 220 AC volt in the AC point. Then you get a voltage output of this transformer. If you get it, then this transformer is working. Now we have to understand what is the ampere of this transformer. If you get here 12 volt AC or 24 volt AC, whatever it is, then if you put here 24 ohms resistance across this two pole, then if you get 24 volt or 12 volt, if you use 12 volt, that means you have to use here 12 ohms resistance here, and if you use 24 volt, if you get 24 volt, then you put here 24 ohms resistance here. After that, if you get 24 volt or 12 volt output of this point, then that means it is give you 1 ampere current. If you get 24 volt AC here and put 12 ohms resistance here, and you get, after that you get 24 volt, that means you get 2 amps current. Now how can I tell this? V divided by R is equal to I. That is a simple formula. So when your V is 24 and R is 12, that means I is 2. Now 2 into 2 into 12, that is your wattage. So when you test this transformer, that is the result. I just calculate it just now. 24 into 12 into, that is your ohms, into 2 into 2, that means 48. That means you have to use here, when you test this transformer, you have to use here 50 watt resistance for 24 volt and 2 amps current. You remember that. If you put lower watt, I mean 20 watt or 10 watt, the resistance goes to be burned out. Don't forget it. So you have to calculate the wattage of this resistance first. After you get your transformer, and if it is 24 volt 2 amps, that means primary current is, that means what is the wattage of this transformer? 24 into 2, that means 48, that is your maximum wattage. So 48 divided by 220, that means 0.218 your maximum ampere of the primary. So you use here 0.5 ampere fuse in here. After that you can get your fuse value. 0.5 ampere fuse more than enough to drive this 2 ampere 24 volt. Okay, I think you understand that. When you get 2 ampere current from the transformer, that means you have to use the rectifier more than 4 amps current. You always remember that, otherwise it going to be hit and you get a problem. So you can it is better to use 5 ampere rectifier here. After that you have to calculate what is your maximum DC voltage. If 0 to 12 your output voltage, that means maximum output voltage into root over 2, that means 16.97 volt DC you can get here. Root over 2 always into with the AC, then you get your DC voltage. If it is 24 volt, then 24 volt into root over 2, that means 33.94 volt DC you can get here. Now we have to calculate the value of this capacitor. Just hold on, you have to first calculate the polarized capacitor here. When you use 2 ampere here, and that is your maximum DC current, DC voltage, that means you come here and look at this. V into I is equal to W, all we know that. So when V is your 33.94, approximately 34, but I calculate here 40 volt into 2, that is your wattage. 2 is your ampere, that means that is your wattage. And also you have to know that when you get your wattage, that means you have to multiply with 2 and you get your minimum microfarad value. You have to use here 80 microfarad, but I am always going to 100 microfarad. And when your output voltage is 40, that means 40 into 2, 40 into, I am sorry, there is a mistake, 40 into 2 is your output capacitor voltage. 40 into 2 is your capacitor voltage. So if you can use here 100 microfarad 100 volt capacitor in this point. And when you 100 microfarad 100 volt capacitor use here, that means in the capacitor there is a big coil. So your high frequency cannot through this capacitor, In that position, in that moment, you have to use a small capacitor to filter a high frequency. For that I use here 0.1 microfarad, and the value also 0.1 100 volt. You also report same value output of this point and use a Henry coil, that is a micro Henry coil, that is used for better filter of DC. After that you get your capacitor value here. Now you get your output voltage here. Now we have to calculate the resistance value of this resistance, because we always use here a lead. This is coming in not for that. One more thing, you have to use here a fuse for safety, and this fuse value more than 2 amps. It is very easy and simple. Now we are going to calculate the resistance value of this resistance. That is your 40 volt. The lead maximum ampere is 50 milli. So we are not going to 50 milli, we are going to 30 milli. Then 40 volt divided by 30 milli is equal to 1333.33 R resistance you have to use here. So you can use here 1.2 kilo ohms or 1.5 kilo ohms. If you use your 1.5 kilo ohms, then your lead is little blurred, but always remember it will work long time. And what is the output, what is the resistance wattage? I calculate here 0.03 ampere. So 0.03 into 0.03 into the maximum resistance value 1.2, that means that is your wattage. So you can use your watt resistance, no problem at all. Now we get a DC, perfect DC voltage in here, that is 40 volt. After that we use here LM317, all are they is LM317, and we also use a heat sink for this IC. You know that, I think. If not, remember it. And that is a diode. You can use here 107 or IN 4007. It is very easy and simple. You can get it, no problem at all. There is no high frequency diode need to do this, because that is a DC voltage. So there is no frequency at all. So you can use just feedback for this diode. You use here a feedback diode. It is used for feedback, and you have to put here 10 kilo potentiometer in this point. That is your adjust pin. That is your adjust pin. So when you value, when this potentiometers is going to vary, then you get variable voltage here. But here is a also feedback diode in forward bias. That is your high voltage and that is your low voltage. So high voltage cannot through this way, but little voltage through this way, no problem at all. After that you have to use here a capacitor. The maximum value is 10 microfarad. I tell it from the data sheet. That is your maximum value. And when you get here 40 volt and here is the resistance, so you can, your capacitor voltage may be, you can use here 63 volt cap, and that is for here and here also. That is a DC filter capacitor. And when you use this capacitor, then you have to same thing in here 0.1 microfarad. Why we use that, I already told in this part. But you have to do one thing. After you get your voltage, then you have to put your oscilloscope or CRO output of this point, that is your output point. I have to written here, that is your output point. When you put your CRO in here and you notice that there is so many noise, then in that moment what can you do to filter this noise? First of all, you have to calculate the frequency range. What is the frequency range? You get it from your CRO, then you decide what is the capacitor and what is the resistance value we have to use here for this high frequency filter. After that, you do one thing. You put here a resistance. I have to draw here. Just hold on. Now you can see here, I put here a capacitor and a resistance in series. Why you get more high frequency here? Because that is a cosmic effect, and other spike also come through this line sometime. So if you use here a capacitor and a resistance in series, that capacitor value 47 pf, 22 pf, something like that, but you have to calculate the capacitor value from the oscilloscope output. I think you understand everything, and I have to tell one thing here. The IC is LM317. According to data sheet, when you get 12 volt, that means your maximum input voltage is 22 volt. That is the maximum input voltage. You can get 12 volt from the output, and you can put here 34 volt, but these ICs are going to be hit. So if you get here 24 volt and it is 0, then 12, then 24, then you use here a switch for better performance. When you want to drive below 12 volt or below 12 volt, then you put your switch to 12 volt max, and if you get be above 20, above 30 or above 20 over 12 volt, then you put your output, then you put your switch to 24 volt, so you can get better performance. I cannot draw here, but that is a simple. And you also use here a fan, cooling fan. It is much more better to do this circuit perfectly. I think you understand everything. Please, you know what to do. Please do this. Okay, thank you for watching.